So this question is still in the topic of real numbers, and it's about the absolute value. Notice that there is a term absolute of x plus 18 as well as absolute of x minus 22 on the left side and 40 on the right side. And you need to notice that the sum of 18 and 22 is 40. So you need to guess and think, is it a coincidence or not? So right now our main focus is going to be on x plus 18 and x minus 22 and 40. So I'm just going to give this one as a, well, absolute of a, because we won't care about this term right now. So what we'll have is, well, I'm going to rewrite as absolute of a first, absolute a plus absolute of a plus absolute of x plus 18, then absolute of x minus 22 equals 40. So the first thing that we need to do, if we're gonna plug in any number, for example, suppose that number is greater than 22. For example, if I plug in x as 25, what we'll get is absolute a plus absolute of 25 plus 18 is 43, right? And plus absolute of 25 minus 22, which is 3. And the right side is still 40. So here, absolute a will be negative 6. So in this case, this is impossible since an absolute value must be greater or equal to 0. So in this case, if x is more than 22, it is impossible. On the other hand, if we try x between negative 18 and 22, because we need to divide it into three groups. The first one being x more than 22, which is here. The second one being x less than 18, which I will write later. And the third one being x with values between negative 18 and 22. So here, if x is more than 18, is more than negative 18 but less than 22, for example, let's say x equals 0. If we plug in x as 0, we'll get absolute a plus absolute of 0 plus 18 is 18, plus absolute of 0 minus 22 is 22 equals 40. In this case, we'll get absolute a as equals to 0, which is still possible since an absolute can also be 0. On the other hand, as I said before, we need another group which is x, which is less than negative 18. For example, if x equals negative 20, what we'll get is absolute a plus negative 20 plus 18 is absolute of negative 2 plus absolute of negative 20 minus 22 is absolute of negative 42 equals 40. In this case, absolute a is 40 minus 44, which is negative 4. Still, it is below 0. The value of it is still below 0, as in the case 1. So in this case, when x is more than 22 or less than negative 18, there won't be any possible value of a. So the only possible value of x must between negative 18 and 22. So this one here is impossible. And another condition more than x, which is between negative 18 and 22, is, well, if any number, we substitute any number in this case, notice that the absolute a will always be 0. For example, if I change my number to 1, it shall be absolute a plus absolute of 1 plus 18 is absolute 19, and absolute of 1 minus 22 is absolute negative 21, which equals 21 equals 40. As you can see here, absolute A would also be 0 as when I substitute x as 0. So not only does x between negative 18 and 22, but absolute A must also be 0. So what do you mean by absolute A equals 0? Well, let's say, I give A as this one, so I'm gonna rewrite it back. So it means that absolute of x to the power of 4 minus 30x to the power of 3 plus 155x to the power of 2 then minus 270x plus 144. This one must equal to 0, but the x value must be between negative 18 and 22. So what is a simpler form of this one? So if you notice, or if you learn a lot of math and you've done many problems in the past about polynomials, you notice that x minus 1 times x minus 2 then times x minus 3 equals x to the power of 3 minus 6x squared plus 11x and minus 6. And this, as I said, this is not a coincidence. So if we times that one with x minus 24, some may ask, why 24? Because negative 1 times negative 2 times negative 3 is equal to negative 6. And as you can see here, there is positive 144 here. So if I times negative 6 with negative 24, the value will be 1 plus 144, which, we need to try so that we may know. So if I times this one with x minus 24, what you'll get is that, the first one, x to the power of 4 minus 24 x to the power of 3. The third one here, minus 6x to the power of 3, then plus 144x to the power of 2. Then this one here, plus 11x squared plus minus 264x, and then minus 6x, and then plus 144 in the end. What we'll get here is x to the power of 4 minus 30x squared, which is this one, and plus 155x squared, which is this one, and minus 270x plus 144. So x to the power of 4 minus 30x to the power of 3 plus 155x squared minus 270x plus 144 is indeed equal to this one. So it means that our assumption is correct, in which this one is derived from x minus 1 times x minus 2 times x minus 3 and times x minus 24. So the value of x which gives the equation equal to 0 is when x equals 1, 2, 3, or 24. But in this case, you need to be aware that x must be between negative 18 and 22. So the value that we can't use is 24. So in this case, x has 3 values, which is 1, 2, and 3. And in this case, A and B and C are the answers of this equation. It means that there are A and B and C, but we still don't know what A and B and C are. So there is still one condition that we can use, which is A minus B to the power of C gives us a maximum value. Maximum value. So we need to try. What if A equals 1 and B equals 2 and C 3? We need to try 6 cases. So the second one, A equals 1, B 3, and C 2. And the third one, in which A equals to 2, B 1, and C equals 3. Fourth one, where A equals 2, B is equal to 3, and C equals 1. The fifth one is when A equals 3, B 1, C 2. And the last case is when A equals 3, B equals B equals 2, and C is equal to 1. So the first case, the value is 1 minus 2 to the power of 3, which is negative 1 to the power of 3, which is negative 1. The second case here, 1 minus 3 to the power of 2, which is negative 2 to the power of 2, which is 4. So the first case here is gone since it is less than the second case. The third case here is 2 minus 1 to the power of 3, which is 1 to the power of 3 equals 1. So this case is still 1 is still less than 4. And this one here, 2 minus 3 to the power of 1, which is negative 1 to the power of 1, which is negative 1, which is again less than 4. The fifth case here is 3 minus 1 to the power of 2, which is 2 to the power of 2 or 2 squared, which equals 4. See that these two values are equal, so we'll keep that. And the sixth case here is when A equals 3, B 2, and C 1, which is 1 to the power of 1, which is 1, still less than 4. So in this case, the maximum value of A minus B to the power of C happens when first A is 1, B is 3, C is 2, or A is 3, B is 1, C is 2. But they didn't ask what A, B, C are, so they just asked what's the highest value of A minus B to the power of C is. So the answer here is, well, the maximum value that we have, which is 4. So here's the end of the problem regarding this actual value and real number. So I hope you like it, and if you have any comments, please leave it down below and I'll try to answer with all of them as soon as possible. So thank you all for watching this, and see you guys again next video.